Alright, so I just showed you how to find z-scores. Let's do some more of that. Finding z-scores, analyzing them, looking at the normal distribution. It's a really big chunk of the course because we're going to use z-scores to predict stuff. We're going to use z-scores to find the probability of different things. Z-scores are pretty important. I got ahead of myself. Okay, hang on. I showed you how to use standard deviation. Sorry. I showed you how to use standard deviation and then how to find, once you have the mean and the standard deviation, how to find your boundaries. That's what I showed you. I'm about to show you z-score. There we are. Okay. Z-score. Excuse me. Alright. Totally on track now. Alright. Z-score really is just how many standard deviations away from or below mean is. Okay. So we'll get something like 1.25. Alright, and that means it's 1.25 standard deviations away from the mean. Or we'll get something like negative 0.7. That means it's negative 0.7 below the mean. Okay. And so the purpose of the z-score is to take data, and they might be totally different data. One might be a test score from one test, one might be test scores from another test, one might be, data about, I think of, we're gonna, I can't think of one off the top of my head. It'll come to me. You just take like unlike data, and so you can compare them on the normal curve. A z-score, we'll learn later, is related to a z distribution. That's later. All right, a z-score of 0, that's the mean. It's right in the center. So when we did this guy, either one, here, this is 0, this is negative 1, this is negative 2, this is negative 3, this is 1, 2, 3. And 0 is the mean because pretty much everything is centered around that. Alright, so here we are. They have two different formulas in the book, but I want you to notice some patterns. Alright, we have the term. That's what x is. X is the term. Alright, then we have the mean. Mean. So is the value, the term minus the mean. And then it's divided by the standard deviation. Standard deviation is this sigma right here for population, or it's S for the sample. So it's really just one problem. Value minus mean over standard deviation. And so sometimes you'll have standard deviation, like you'll have these, or sometimes it's a list of data and you need to find it. Alright, so a student scored a 65 on a calculus test. So the mean, x bar, 65, she scored, I said she because I'm math and the girl. On the calculus test, the mean is a 50, so that's x bar, 5. Standard deviation is 10. Right, then she had a history test. Right, and she scored 30 on the history test. Mean was 25, so she did better than the mean. standard deviation is 5. Alright, so the formula is x minus x r over sigma. Value minus mean over standard deviation. Alright, so I'm going to do 65 minus 50 over 10. I get 15 over 10, 1.5 for the calculus test. Then I get 30 minus 25 over 5. That's 5 over 5, which equals 1. Alright, I'm going to compare them in a minute, but I want to do a couple other things. Okay, so for the calculus, or for the history test, you get the z-score of 1. That means it's 1 standard deviation above the mean. For the calculus test, I got 1.5. That means it's 1.5 above the mean standard deviations. Alright, so I'm going to keep those in mind. Anytime you're like watching these videos, you should pause if I go on to the next thing too fast and you're still writing notes. Or you could like pause and rewind if you need me to say something again. Calculus 1.5 history. Alright, calculus was 1.5, history 1. Alright, let's look at calculus. Calculus, mean of 50, standard deviation of 10. 1, 2, 3. Alright, so we get 60, 70, 80, 40, 30, 20. Alright, so I took the mean, I just added the standard deviation, subtracted the standard deviation. Alright, now 65 happens here-ish, in between 60 and 70. I don't need perfection, I just want progress. Forward progress would be fabulous. Right, mean of 25. Standard deviation of 5, so this is 30, 35, 40, 25 is 20, 15, 1, and then 10. Alright, and she's a mean of 25. No, she's a 30, so she's right there. Versus here. Okay, here's what we know about the bell curve. 0, -1, -2, -3, 1, 2, 3. Alright, and the calculus is 1.5. So it happened right here. Halfway between 1 and 2. Versus remember, this is 0, -1, -2, -3. This is +1, 2, 3. And then history was 1. So it happened right at the first standard deviation. If we superimpose these, so I just put them on top of each other, we're just going to draw it over here. Alright, and so 0, 1, 2, 3, 0, -1, -2, -3. Alright, and I need to draw it at 1.5 here. Alright, so she did better on the calculus test. A couple of things. The closer you are to 0, the closer you are to the mean. And so she did better on the calculus test, but she's closer to the mean on the history. So sometimes it's better to be closer to the mean, and sometimes it's better to be further away. On intelligence, we generally say it's better to be smarter. Or on tests, it's better to do better. On if you're like in a neighborhood with your housing prices, you probably want to be closer to the mean average of your your house price probably needs to be in the mean, near the mean, like if you're trying to sell your house. All right, so let's do z-scores of these guys. All right. I'm going to go back. We standard deviation is 4.1, mean is 22.1. All right, x minus bar over standard deviation. Okay, so we're going to do 19 minus the mean over standard deviation. 18 minus 22.1, negative 3.1 over 4.1. Alright, I get a negative 0.8. Then this guy is going to be 23 minus 22.1 over 4.1. 22.1, 0.9 over 4.1, 0.2. Okay, so this one is almost negative 1 standard deviations. This one's really close to the mean, but we knew that. Right, let's do this guy. X bar is, so the mean 22.6, sigma 39.1. Right, our formula, term minus next term minus x bar over sigma is z-score. Right, 4 minus 22.6 over 39.1. 4 minus 22.6, negative 18.6, divided by 39.1. Negative 0.5. That's only half of a standard deviation below the mean because it's in the negative, and so you need to say the negative. Right, 150. 150 minus 22.6 over 39.1. 150 minus 127 4 over that 39.1. We get 3.3. Alright, we kind of knew that. He's way higher than everything else. I'm going to show you later mathematically why it's an outlier. And so also makes sense that he would be in the top 99.7, so it's 0.3 together on both sides. So he would be in the top 0.15%, 0.3 divided by 2, the data, which totally makes sense. Alright, so go work on your independent practice work and then come back and watch the next video. Bye.